Um, so by the last class, we were seeing what is this replica set, deployments, and then services, and like how we have to execute these commands, the kubectl command that we have seen today, and what are the type of deployments that available in the Kubernetes as well as the other deployment strategies. So we have seen that yesterday. So in the service, we were just exploring the cluster IP. Cluster IP in the sense, like in the node, uh, a service will be created and multiple pods will be running. So in order to access your application within the cluster, you will be using uh, the type service type called cluster IP. That by default, if you don't give specify the type, the cluster IP will be created. So and there are plenty of other services are there. So one is first one is like cluster IP. We have seen that. Second one is like node port. Node port. Node port instance. So this is cluster IP. So in order for your application somewhere in other namespace or within the namespace, if you have to access this application, you first need to reach out this service endpoint. Then the service will route the traffic to different ports. Okay, that's the use case of this service. Node port means if you want from as an external in the external world, there will be plenty of users will be sitting there. They want to access your application. So what will happen here is like your pod is going to deploy in someone worker node machine like consider it's a V1 and V2 is there. When you create services with node port, uh, it opens a port in all the machines. If suppose like a 31,000 port is opening, mostly these IP ranges you can see above 30,000, like above 30,000 to 30,800 something. In between this range only, you will whenever you deploy node port service, you can see the port numbers in between this range. So this port will be opened in all the worker nodes. So if you access this if you have this public IP or private IP of this machine and you are in the within the V network, if you access this machine this port number, you can still access the application. That's the use case of node port. And third type is load balancer. So load balancer instance, in cloud there is something called load balancer is there. What is this load balancer do to like consider it's a pod or instance or any VM that you can consider. Load balancer is going to sit in front of this one. If an user like tries to it to the application, the signal first comes to the load balancer and the traffic will be routed to different instance or pod. So the third type load balancer itself, it actually going to create a load balancer in the cloud. Like if you create a service type of load balancer, it actually creates an layer 4 or layers like mostly it's like layer 4 load balancer. Layer 4 means that network layer. So there is something called OSI model. You just keep remember the thing. There is something called OSI model is there, in which like there are 7 layers are there, 1 to 7 layers. To access any application, the seventh layer is called application layer. The fourth layer is called network layer. Mostly this load balancer is going to create a network load balancer in the cloud platform. The fourth type is external name. The fourth name is external name. This external name mostly be used for any private resource connections. Suppose we consider this cluster is in AWS. We have this cluster in AWS. In AWS, some database is there which is called RDS. Like you want to create an alias for that. Alias instance. Alias means you give a pet name for that. Okay, consider like your full name is like Lokesh, but I'm like calling you like Lokesh or Loki or something, right? So that is I'm giving him pet name or like alias name, how the convenient name for me. I'm keeping the alias name for you. So this external name is used to keep an alias name to any of the external uh, RDS or any of the external resource in the cloud platform. So these are the four type of services in Kubernetes. You can see I mentioned those things in the slide. So if you go to these things in the diagram, if I zoom it, uh, you see whatever I told. It's a if you see it's a cluster IP. this is the outer layer is cluster, the pods are running, and the traffic, the cluster IP is used to run inside the run inside the cluster. If you want to access the application inside the cluster itself, then you will reaching the creating the service called cluster IP. The second type is node port. Node port, see, traffic is coming from the external world and it reaches your node. The node means the worker machines, and then that node will be routing the traffic to service. The service will route to the pod. That is node port. Load balancer instance, it in cloud it creates an layer 4 load balancer for you, from where you can receive the traffic. External service means you have to access some resource within the like with the within the cloud platform. You create an alias name for that and use this thing. So last time we were seeing in the project we were seeing the cluster IP. So what's the difference between this is how the cluster like a declarative file is going to be look. The API version is like v1, the kind is service. In the metadata I mentioned some name. This selector is equal to app.nginx. So these labels must also present, it should be present in your deployment pod section. So this service, by using this label mismatch alone, the service is going to route traffic to the pods. And in the port section you will be just mentioning the protocol and which port the service should open, and in the uh, target port means and the deployment, the pod where it is running, you have to specify that port. So that's what we have seen in the last class. But if I want to create a node port, then you by if you see like kubectl wait all let me, I'm not sure it's running or not. Yeah, it's still running. If you see kubectl get service, and then what is that, nginx service is there. -o YAML. Why I'm showing YAML file means I didn't specify the type here, but if you go to this YAML file after this resource creation, this some of the parameters will be added automatically. If you go see the type here, see type is cluster IP. If you don't specify type, it will be considered as a cluster type. Now what I want to do is instead of this cluster IP, I want to create it a node port. So what I have to do, like I will do like kubectl delete service, nginx service. I'm deleting the service. Uh, Now if I want to use other type called node port, so I mention the type. I'm mentioning the type here as node. I'm mentioning the type as node port, and that's it. And then for node port, you have to mention the port number where you should receive the traffic. Um, if we go to my slide. See, in cluster IP, you don't need to specify the node port number, but if you are giving the type as if type as node port, you either you can mention this port or this port will be assigned automatically. What this node port means, it will get the port number from the machine. Now let me I given the type as port node port, and I want to run this one kubectl um, apply -f and then service.yaml. Now you see a service is created. If I do kubectl get all, you will be seeing a node port is running, and you see this port number, this service is running. It opened a node port in the 3200. So that's how we access the application. So if I go to my localhost, I think it should work. Let me go for localhost and then 32,000. Uh, yeah, it will not open unless you have to create uh, unless you have to create the ingress. So we will be seeing that in the next step. I think this is fine for now. So the rest, this load balancer mostly they will create when if you have the Kubernetes in cloud environment and then you want to spin up a L4 load balancer, then you have to use this. XNLM is to like access any resource in the cloud. So let's go to the next one. So we'll come to the stateful states and the daemon, daemon state is there. We will come to see at the end of the class. Let me go to some other topic called ingress. So up till now, what I told, um, like let me erase these things. Um, now, so now we are going one more step further. So what I told, this is my cluster. Okay, this is my pod. I'm not going to highlight everything. Pod. Then there is something called service is there. Service will reach the traffic. Transfer the traffic to pod. Now one more thing is going to present in the entry point, that is called ingress. So mostly nobody is going to expose their node port, because why like if you are like opening the port number in all the worker node machines, that is an not is a good way, and it's not a good methodology, because the hackers can know that this port is open. They will try to like do some do some checks on the port and try to hack some details from your cluster. So we don't want to be exposed to node port. In that case, you actually create a something called ingress. What will do, the end user will always not always keep not remember some domain names, right? If it is like phoenix.com or something, consider my domain name is like phoenix.com, so he knows phoenix.com. So here the ingress will like after the DNS mapping, the ingress will get the traffic. Ingress will then forward the traffic to service, and the service will forward the traffic to port. Then what configurations what I am going to have in ingress means, I'm in ingress I will be specifying what my DNS name. That means what is my domain name, like what's my website name is going to be. It's like phoenix.com, and then I will be giving TLS secret. What is this TLS secret? What is this TLS or SSL? SSL in sense, already we have seen, like if an application is running on HTTPS, that means like hypertext transfer port, secure hypertext transfer protocol, which is by default it is going to run on port 443. In order for your website to run on 443, there is something called in the throughout the world there is something called CA is there. That means certificate authority. So because you are creating a phoenix.com, right? This phoenix.com is valid or not. So this CA only is going to approve it. Where there is something called you can just remember this thing. So when you want some website to be hosted, there is something called you have to raise an CSR first, certificate sign report. Okay, you have to first request a CSR report, which will generate a private key with you, and then you submit your request to the CA authorities. Then CA authorities will approve it, and then they will send you the public key. Okay. Now you already send the private key and the CSR copy to for authorization, and they will be giving you a consider like they are giving you a public key here. Now you have public key and private key. So I've initially in the initial class I was told, consider this private key as always a key, as a, like a door key, and the public key is always like going to be your lock. These details, this private key and secret key details should be present somewhere in the ingress. That's what we call SSS offloading. Because so in order for user to reach your application, this transfer between your user and the ingress should be in the secured mode. So whatever the information that user sees should not be seen by others, because in the throughout the internet there will be multiple hackers will be sitting there. They're waiting for some information to get passed. If it is unsecured, they will try to break it and they will try to read that information. It should not be happen. That's the reason we are running the application in HTTPS, and we specify the public and private key in the ingress. It will take care of this SSL offloading as well. Once it comes, then the traffic will be routed in the HTTP. HTTP means port 80, because inside the cluster we know I no need to verify the SSL, because here it's a private one, right? Obviously I know no hackers can come inside this thing, because I already have an this security configurations in the ingress level itself. So we will see the ingress configuration now. like what I do. See, why am I each and every time I could have been pasted these files in my local system, but you should know like how I am accessing this documentation. See, I'm also coming first time now. Like I type ingress Kubernetes um, YAML, something I put YAML or manifest, anything you put. And the first section will come from the Kubernetes.io documentation. You go there, mm, and you see, go inside. You just copy the thing. I'm just copying the thing. Uh, I'm going to delete the service which I created, uh, and then I create with the cluster IP again. Hmm. If I do kubectl get all, what I have deployment which is running in port 80. If you go deployments.yaml file, it's running in the port 80, and then I have a service which is mapped with this port number and port number of the service and the port number in the deployment file. Now one more service I'm going to create is which is ingress. So what I give, uh, in order for you to create any ingress, first I will give something like uh, you see, it's mostly the format is going to same. The API version is going to be like networking.kats.io./v1. So this will remain same. Then next the key value pair is like kind, which I mentioned as ingress. Then the metadata, what name I should keep for my ingress. I'm just keeping like nginx ingress. Uh, and then the third is like nginx ingress kubernetes IO rewrite target at slash. You leave it. You just follow this annotation. This is like a global annotation. Annotation means like you need some configurations here so that ingress can change from the default behavior. So that is what we will mostly giving in this annotation section. Mostly all the pods which is running service or whatever resource Kubernetes, and we will have some annotations that are mostly like some default configurations. You ignore that. Now what you know, like mm, there is a rules is there. Then I give my path is a slash and prefix. Here what you should give is like in the service, if you see rules is there, http path type backend service name. In the backend section, if you see this entire section, what it says like um, mm, in order for you to use this ingress, you should you have something called ingress class name. Where this ingress class name will come from? Because I told right multiple things like this SSL offloading, this taking care of domain name mapping. So this ingress will do this by help of something called ingress controllers. This is one of the important topic because each and every cloud platform this ingress controller is going to be get changed. We have different ingress controllers. One is like the most common one is nginx. Nginx is it is a web server. Mostly if you are hosting any website, like if you want to do some reverse proxy or some web server application, hosting web server application, everything is done by this ingress controllers only. So there are multiple ingress control. If by default most everybody is using Nginx. If it is in cloud, they will be using called ALB Nginx ingress controller. It's just like a Elm chart. We will see then what is Elm chart and different use cases. We just install the Elm chart. That's enough. It will be in the background. It will create different resources. So that will take care of this total mechanisms whatever I explained. So it is my local system. I cannot have this Nginx. Like I will be having this one sort of nginx ingress controller now, and the ALB is the ALB ingress controller is available only in the cloud. So what I'm going to do, I'm going to run one more command called minikube add-ons for enabling the ingress. Let me go to my cluster. Hmm. So I run this command. Minikube means I'm using a minikube to run the Kubernetes cluster. I'm adding some additional parameter to enable ingress. Now what happens? You see, like minikube add-ons enable ingress. Now, yeah, ingress controller is going to run here. Mm, let's write. It's adding the it's adding on. So in the backend service, there is something called service and the name. You know what service name you have created here. What service name you created something called nginx service, right? You copy that and then paste it here in the deployment in the ingress YAML file. You just give the backend service name as nginx service. See, and we know that service is running on port 80. We have defined the port number as port 80. So you give that and you just leave all the rest everything, you just leave it, use the default configurations. Now if I do kubectl uh, get pods and -a, I'm just want to check, see, something called ingress nginx namespace has been created where this ingress nginx controller is started to run here. So this is what I told. So we are by using the add-on, a minikube add-on, we have installed the ingress controller in my local. So now, mm, once again, mm, I'm just changing some configurations here. Uh, because I want to create a domain name in my local and want to show you my application is running somewhere here. Phoenix I'm getting like Phoenix example, like Phoenix demo.com. I'm setting my domain as Phoenix demo.com. Like how it you previously when I told for in order to you to like have any domain names, you should be registered in the GoDaddy or some Namecheap or in any other third party domain services. But in order to have these domain names get resolved in the locally, I don't need these things and all. Okay. Um, I'll create an hmm. What I do now, I will first run this ingress configuration and then see it's working on it. Like kubectl apply -f ingress dot yaml file. Now you see ingress is created. If I do up like check now kubectl get ingress. Hmm. Yeah, ingress has been created, but you see there is no domain name as matched for this. Anybody join now? Like,
Hello.
yeah. If you see Nginx ingress configuration now, yeah, kubectl get ingress Nginx ingress -o YAML. See, if you there will be some section called ingress class name. So when we we didn't specify this parameter, but there is some we installed this ingress controller, so that provided this name by default. Ingress class name is equal to Nginx. So when we have something called phoenixdemo.com, and we have a load balancer. We have a status load balancer IP is 192.64.2. Now, what I do is like if I type minikube IP, it is going to give me some IP address. What I will do in order to set a domain name in my local, there is some folder called Windows C. In Windows C, something called uh, let me check the path. I'm just checking for the host file because in the host file you can there it is here. If you see, if I give like this, like if I go to my locals in Windows System 32 drivers etc, there is a call something called host file is there. I'm just opening in the notepad. Hmm. And giving the DNS entry here. So what is my system IP is like 192.168.4.2. Okay, I give this IP, I copy this IP and then give it here, and then here I'll just give my domain name. So what will happen here? So this is called local resolver. Okay, you no need to purchase some domain or something. You just create. You just have some local domain names because your system when it's before going to the internet it will check if for this particular for particular this domain is there any IP address specified in the local host file or not. If it is not present alone it will go to internet. First it checks my laptop if the domain name if for this particular domain name any IP is available, so it will route the traffic inside itself. If not, then only it goes to the internet and to get the correct public IP address in the backend. Now I know it is running in 192.60.4. Now I go to this Phoenix. Um,
Uh, Hello.
yeah,
Yeah. In that notepad, it says end of section. After that, only we paste out the port number and
yeah. You
name of
just
it.
you just space you type like minikube IP or like if you know the IP address of your machine, uh, then see you can see that output from different layers. Either you can type minikube IP, it will give return to the IP address of your Kubernetes where it is running. This 192 series means it's like a private IP only. Okay. Uh, See in the ingress which I created, it that the status the ingress it's running on the port. It specifies the public private IP. So I just in the etc host file I modified for for this domain name. This is the IP. It should match. If I go to this .com, I either should see. Wait. It should work.
We saved the notepad.
No. It's something else. Uh, hmm, leave this, but just observe the concept. This how it should you should be configuring Ingress, and Ingress will give you some the domain name or something. Then you access the application there. So in my notepad file, I have the same entry. I think something has to be restarted here. Wait.
Can we put at the 28th line the same prompt?
No. That's not an issue. I got it. Like you want me to access like this. I don't think.
Yes.
Issue is something else. We can figure out later. But this you just observe the concept. This how you should be configuring this, because in this ingress, if you have one more, if you have like multiple uh, applications are running, you want to access them in by different host names. Like what you do is like you just copy it, this HTTP, and then if you think there is one more in the here like HTTP. Uh, so consider the rules. We have only one host name which is called phoenix.com. If it is like slash app one, it should go to this service. If it is not, it should go to app02. This how they do this path based routing and all. Okay, if it is like app02, if like after application or after this phoenix demo.com, if you specify app01, it should go to the first service nginx ingress. If you specify app02, it should go to the another service which is running in this cluster. So that's how you make the difference. So this is what we call like path based routing, and this is how we can achieve it. uh, Let me move to other topic now. Um, you see, if you have, I specify the same thing here. If you have two applications, you have to find the same thing in different parts. Like slash API will goes to API service and slash web goes to web service. You have to create the names in such that way. Mm, Here I was explaining this path-based routing and the host-based routing. Host-based routing in sense like so you will having different host name, like phoenix.com is a single host name. Under that slash for slash app01 it was routing here. The first service as slash app02 it was routing to second service. If you go to the host-based routing, the domain names itself will get changed. So here the domain name for the first service it should be like web.example.com, and for the second domain it should be like api.example.com. So by this you will either of this you can achieve this thing. Mostly people will not use this or like host based routing. They will have a single point of domain like any of their example domain or any particular domain that they have, and they will do the path based routing. So it has been mostly used in all the organization like the path based routing things. So under this, here only there is a separate section for TLS secret. So I already told what is this TLS secret and all. So we will create something in Kubernetes. There is something called secret is there, where you add your TLS dot certificate and TLS dot key file, and you give the secret name here under the host and then the TLS section. You just give the secret name. So this secret name it is just a name mapping here. Inside this in secret you will have this like the public and private key. I don't have any public key and private key now. I can do some self-signed certificates, but I think for you just remember these things. If TNS offloading, like SSL offloading is occurring in the ingress, and we just specify the secret name here. Like in mostly cloud, what we'll do, they will create this TLS secret in the Kubernetes, or they will map it from the something called like Amazon certificate manager is there. They put the certificates there, and they will give the link here. So it will do the SSL offloading. Mm, Now the next resource will be like config maps. What is this config maps? So for, initially when I was telling like if any application is running, there will be some environmental variables that the application needs. Okay, consider it as an application. It like in order for this application to run, there are some certain environmental variables that are needed. Okay, like the environmental variable like env is equal to dev, or it should be have some domain name here. What's my domain name for my application? You specify that. So these things are like are some values. Some key value pair will be there. Okay, mostly this environmental values are like key value pairs. So this key value pair it should be added in the application. So that's where something called config maps comes to the Kubernetes config map. Similar to config map, one more thing is there that is called secret. Both the config map and secret Kubernetes resources are same, but the main difference would be this secrets are like base 64 encoded. What is this base 64 encoded means? It will be masked. If you try to open see that what is the text there, you cannot see either. It will be having some like different like words will be like xj or something like, and it will be in any format that you cannot read that format directly. Like instead of like plain text, it will be in like a base in 64 encoded format. So that's how the people call it. Okay, now let me go to the documentation part. I go to config map Kubernetes, something comes there. I go inside this and I copy this thing. Mm. So I will take from my here. I'm typing a cm.yaml file. Cm means config map. Now after I created, now you see this also same thing. API version is equal to v1, kind is equal to config map, metadata is equal to, I give the name as I give the name as like some nginx uh, nginx config, and the time mode setting as 30 seconds, and the app mode is equal to production. Okay, I just give this config map, and then I do kubectl apply -f and then cm.yaml.file. I haven't saved the file. Oh, sorry. Hmm. If you do kubectl file, now your config map is created. If you do kubectl get cm, that means config map, you will see a config map which is created with nginx config. Now, like how I can map this config maps to the deployment. This is the important part. If you go to my pod.yaml file, I have a pod here, right? Let me rename this pod with different name. I give it as a demo or something. I give the label also demo here. I give the label as a demo and this also demo. uh, Let it run in the same nginx port. Now, how I have to import this config map inside the pod section? I just go to the documentation part itself to go somewhere. Either there are two ways to mount a variable inside. One second, I'm coming. Wait. There are two ways. Either you can mount the environmental variables as environmental variable as like a volume, or you can mount it as an like environmental file itself. So for that, first we will learn how we can mount that nginx config as a environment thing. So let me go here. Here, let me copy. Let me copy this section in parallel to this like image. I added some section called env, and I know it should. This how it should be. So what is my config map name that we created? It's nginx config, right? Should I should give the name here. Okay. Uh, okay. This is how the format should be. Environment value from config map key value. What is your config map name here? You just give it as nginx config here. On what is your key name for this one in the config map? It is app mode, right? I just copy that app mode and put the key name as app mode. Now you see, this is a section. I'm going to read the like the config map. Like I specify the section env value from config map key reference name is equal to config map name is equal to nginx config, and what's the key name is app mode. After this, what I do, I like trigger the kubectl get pods, and then sorry, kubectl apply pods dot yaml. Let me put it. There's something. There is some syntax issue. Sorry. Hmm. I think I removed the slash name here. Uh, hmm. Now it will work. And the CNV should be parallel to image. You don't worry about this thing. You can even in the examinations you can get you will be have the access to this documentation. You can refer the documentation. I'm just giving the environment as app mode again. Now I am trying to recreate. Now it will be created. So what will happen here? Like now this pod demo is running, right? Demo pod is running. If you see kubectl get pods something, a demo is running, what I do is like I am going inside the container, like see -it, and then demo, and then I give bash. Now I'm inside the demo pod. If I do echo, it is an environment rule, right? If I do echo dollar and then app underscore mode means you will be seeing the environment variable as production. So from this, the application can fetch it. That's how you create a config map and map the config map into pod. Now see, I'm inside the demo pod and I'm seeing the values production here. So that's how we use the config map. There one more thing is called secrets. So let me go to the browser again. Let me check for some like how I can go from here. I already add my reference here. Hmm. So if any sensitive information is there, like some DB username, password, or something, you should be passing that from this secrets.yaml file only. So let me go to my Kubernetes file and let me add something like secret.yaml file. Now I give the secret as like this. You see, it still look the file format is same. API version is v1, kind is secret, metadata is equal to db secret, and type is opaque, and I give some DB username and DB password. For you now to understand, I give it as like admin and give the password as admin123. Config map is just used to map the environmental variables. The secret is used for to pass only any sensitive values are there that you want to fill, that you want to pass. You should use the secret as a service. Now if I do kubectl apply -f and then secret .yaml file. What's the answer then? Let me secrets Kubernetes. Let me use ChatGPT again. Like there are some errors. Hmm. It is not accepting me to give in the plain text code. That's the issue. Now it's been like base 64 encoded. How I can see is like I don't think I have this base. Hmm. If you see, if I do echo hyphen n admin and the base 64 means it will give me value in different format. You see, it is giving in me the admin name in different format. This is what we call base 64 encoder. If I do echo hyphen n and then like what my password is considered, my password is 123, and then I give pipe base 64, and then you see it gives that name in different format. This is what we call base 64 encoded. Now what I do is like what I will do is like, and if I try to create the secret now, it will be created because the secret accepts only the base 64 encoded formats. Now the secret is created. Let me go to my pod again. Um, Now similar to this config maps, I'm going to refer the secret. Mm, mm. In the same env section, see, previously we created an env section and we called the config map here. Like similar to that, I'm creating a one. It's like a three list now, three list, 1 2 3. The last list was we are using for config map, and I know my db secret will be like my I know my db secret name is like it's db secret only. So if it comes to pod, I have a db secret here, and it's like db user and db pass, everything is same. So I just try to do the kubectl apply for pod.yaml again. What I do, it's like because the pod is already created, so let me do like replace. Instead of apply, I give replace. Apply means it will delete the old one and comes up. Still, Mm. Now the pod is created. I didn't make any changes in the template. It was because already the pod is available. That's the issue. I deleted the old demo pod. Now I created it. If I do exe now, if I do echo, both these config maps and secrets are same, but the secret will be like base64 encoded. Now if I do db user now, echo dollar db user, now you can see the value directly as admin here. That's how the application read the value from the secrets. So that's the use case of like config map and secret. The next topic will be like service account. So what is the service account and why we need this service account and all? So suppose my pod is running here, it needs some permission. So we provide the permission by using the service accounts only. In most probably, um, this is pod, and this pod has something in the cloud. It has to do some operations. Okay, so this pod needs some permission to do that. So by using this service account, what we will do, we create a service account, we attach this service account to the pod. This in top of this service account, we do some cluster role bindings, that is we call RBAC. Uh, RBAC and provide the permission so the pod can perform some certain operations. Okay, so that's the use case of service account, because if you want to do some deletion, or if you want to read some details from other pods, if you want to like perform certain operations in the cloud, consider it as my cloud AWS environment. This pod has to talk to some AWS resources and get some details. But then the service account, it should map to service account. That service account should be mapped to some service role by service role. By using that only, be able to access this cloud resource. So for that we need the service accounts. So what I do is like I create a service account now. Mm, I create a sa.yaml file. Mm, and then I paste it. You see, it's still the same. It's like API version v1 kind service account metadata name is equal to read only -a. That's it. It doesn't have anything. It just what the service account will do is like the service account will generate some tokens for you. That token will be used to access the other applications. So what I do now, kubectl apply sa.yaml file, and then apply -f, and then sa dot. Hmm. Now it is created. Now the service account is created. How I to map this service account in the pod again is like there is some section for service account. You just specify the name in the spec section, in the container spec section, and below that you just specify the service account name, and then what you do. Uh, mm, Even I'm not sure whether it will allow me to replace or not. Let me try replace -f, and then pod.yaml. It's not allowing me to replace, so I will do, I delete the pod demo and then I create it. Hmm. Now if you see, this service account is got attached to the pod. Now the pod, as if I go inside the pod, like kubectl, I go inside the pod, and if I want to see where is my token is, because this token, it's how it know, it has to it has some permission. You have to go to this inside the Docker container, and then I type in the where run secrets Kubernetes and IO, the service account token is there. By using this token only, now your pod is going to communicate to external services and external resource in the cloud to get some work done. So that's the use case of service account. Let me move to next one. which is like security context. We don't we will cover it later. It's like kind of some uh, advanced topics for you, and then so what I told when we were creating some service account, we were talking about some RBAC. What is the RBAC? RBAC intends like role-based access control, like how you are going to enter into your Kubernetes cluster. Okay, in order for you to perform some operation in cluster, or in order for pod to perform some operation in the cluster, we need there is something called rollback is there. Rollback means role based access control. Okay, you see, I mean role based access control, and this role and role bindings are mapped for you. Okay, if there is any user or any group in your organization, you want to restrict their access in the Kubernetes cluster, you use role and role binding. If there is if any pod is running, you want to restrict the pod access, then you should be creating some cluster role, and you do the cluster role binding. So this both role and cluster role are similar. Role binding and cluster role bindings are similar. Role is specific to users. Cluster role is specific to the resource that you created in Kubernetes. The same thing. So if you go to some examples, here you see. mm, if you see, like I'm creating the API version will be like rback authorization.k test.io.v1. The kind is role. Metadata I'm giving it as a pod reader. I'm giving the namespace in dev. The rules would be like API groups. Resource will be pods. Only and verbs will like get, list, and watch. What this mean? What is this API group means? So mm in Kubernetes, like for each and every resource, like we create like pods, replica sets, deployment services, ingress, whatever. There is something called API group is there. This API group points like on which category this application falls at. That's what we always see in the first section. API version, we see something, right? In this rules, we mention the resource equal to pods, and this role will have only permission to get, list, and watch the pods. It will not able to perform other operations. And then there will be some users will be there. Whatever the role you create, we do the role binding here. In the role binding, in the subject section, you see the name as dev user and the role reference as pod reader. Where we see we are getting the role as pod reader, and we are assigning it to some user called dev user. This how to any external user if comes to the cluster, if any external user comes to the cluster, this how we restrict their access by using role and role binding. If you see cluster role and role bindings, we already seen this one. This cluster and role bindings will be applicable to some service accounts. Okay, um, this cluster role, you consider some cluster role I'm creating here. Like we created now, right? I created a service account. I am mapping that like service account with some cluster role here. What I do, I go here like um, I create some cluster role here dot YAML file. What I do is like kubectl apply -f and then cluster role dot YAML file. Uh, you see it has API version, kind, metadata, and the rules. Any API groups. The resources should be pod, services, namespace, get, list, create table, delete, and then you create that cluster role. And one more thing is there, which is called cluster role binding. I create a cluster role binding. So for this cluster role binding to happen, I'm removing this namespace is equal to dev. So I created a cluster role. Uh, so the cluster role will have permissions on pods, services, and namespaces, and it will have permissions like get, list, and create and delete. Now what I do is like I am going to create one more service account. I'm going to create by command line kubectl create SA, and then I give the name as admin. I going to create some service account called admin. If I do SA means service account, kubectl create SA admin, that means a service account with name admin is created for me. Now for that admin cluster role, I am adding this cluster role. See the cluster namespace is like namespace hyphen admin. If you go to my cluster role, I am creating the cluster role with the name called namespace admin. Now it both will get attached. If I do kubectl apply hyphen f and then cluster role binding and the YAML file. Now the okay, it's asking for namespace as well. I'm going to give the namespace as default. See, if any issue comes, you first read it and see the cluster role binding and bind and namespace binding is invalid because subject to 0, the first index namespace is a required value. Okay, if I given the namespace is default and then if I try to run it, now you see the cluster role binding has been created for me. So that's how, like, now this pod will have whatever the pod will have this admin service account will be able to perform this all these operations. So that's the use of this cluster role bindings, role and bindings. Similarly to that, I don't have any users to show demo on this role and role bindings. Even if that I can, I could have been created. So in cluster, if somebody has in cluster, like how you maintain some permission or something, then you should be telling them like I have used cluster role bindings. By using them only, I have control the permissions. So uh, I think I mostly see either you can create this thing by using the YAML file or you can create them by using the kubectl commands as well. So in the kubectl command pod, you see kubectl create role pod reader, the same things will be there. You create role bindings, cluster role and cluster role bindings. Everything can be created by the command line as well as the imperative commands as well. Sorry, declarative file as well. So tomorrow we'll be seeing about these volumes. Volumes it's a very big section, so I need def to cover them. For now, what we will do is like we will see about what is this daemon set and stateful sets. So we were talking about this daemon sets, right? So what's the difference between daemon sets and the deployments means? In a cluster, there will be different workloads will be there, like worker nodes, like consider w1, w2, w3. Okay, when you run the deployments, how do you control the replicas, right? You control the replica count in deployment, you control the replica count. But these daemon sets, this daemon sets and deployments, both these YAML files are going to look the same. Now you see, like uh, there is some image here, like specifying the ds.yaml file, that means daemon set. uh, and I create, you see my label, my template section, you see API version is equal to apps.v1, kind is equal to daemon set, the name is like nginx ds, labels is like app nginx or a selector. You see this section exactly same as the deployment, no changes here. But no changes, but you see, you are not seeing the replica section here, right? You, apart from that, you see selectors, templates, specs and everything is there. But most people, and here I'm showing you demo for daemon set, I'm showing an like image with nginx. What the key difference means, it is not going to run in multiple replica accounts. um, when you run any daemon set, you mention any daemon set, if you have multiple worker nodes, for each node one daemon, so it is going to run. No matter, you don't need to specify the replica counts here, like how many worker nodes you have, d4, d5, like w4, w5, how many worker nodes you have throughout your cluster. When you run the daemon set, in each worker node one daemon set is going to run. Mostly when we will run this daemon statements, in order to like scrape some metrics from the worker node, like you want to know the CPU and memory utilization or some other, or you are using some other log injector like Datadog. If you want to send some events from the metrics from the worker node, those times you will be running a daemon set. This will scrap the details from the each and worker node and send to your endpoints. So if I try to run this daemon set, you see I didn't specify the replica account. kubectl apply -f and then ds.yaml file. Now see a ds is created. If I do kubectl get daemon sets. Now see, one is decided, one is ready, one is up to date. So no many like because this is only one machine I have. If it have like multiple machines are like multiple daemon sets should be running in different worker nodes. So that's the use case of this daemon set. And one more thing is there, similar to daemon set, we have something called uh, like stateful sets. Uh, I think I covered this pod ML deployment, replica grids, deployment strategies, deployment, daemon sets, Kubernetes service, we covered service, all the service sets, stateful sets. See, we will see the stateful sets once we complete this volume section and all, because that only you understand. Uh, Basically, any application that runs in the uh, runs anywhere, like there are only two types of application, like one is called stateless, one is stateful. What is this stateless and stateful meaning means, consider it's like a web application, like it's Nginx or something, or some backend application. Mostly those are stateless. Stateless in means they doesn't store any data. Okay, that's the meaning of stateless. Stateful means my application is going to store some data. That is what we stateful. Because even the like even this pod goes and come up in Docker itself, we have seen these containers are ephemeral. Ephemeral means it doesn't automatically store the data that generated during the runtime. So we have to map some external volumes to the stateful sets, so the data will be available, always available in the external mode. Whenever the new the replica mode is going down and coming up, this get attached to this physical volume and gets the data. Okay, that's the meaning with like stateless and stateful application. Somebody will ask you like what is difference between deployments and stateful sets. Deployments and stateful sets, mostly the template, the YAML template file configurations are same. Mm, Apart you will be having some volume claim templates here, because that to like store the data, and it will be used only in the like some database application. You see here the image is MySQL. Stateless applications are like used in some web, front end back end, and some Nginx applications are stateless. So I hope you got the difference between stateful and stateless. Tomorrow we will be seeing about um, we will see about this volumes, and yeah, volumes, and then we will see some what are the additional Kubernetes topics are there. Those things and all we will cover tomorrow, and security context is there. So apart from, see, now if you take my pod.ml, whatever the sections we have seen now, or in the pod.ml, we have seen security account, containers, and then we were running a single container. We have some DB secrets, we have config maps, we have ports. Tomorrow we will going to add some more volume claim templates here. So we'll be adding more and more options in the pod. So you see like how many resources we have covered so far today. We'll see about this volumes and security context by tomorrow, and we'll end this Kubernetes class for now, and we will discuss some advanced topics if we have some time, because apart from this there are some advanced topics are there that if possible we will try to add. Hmm. Because I have added the advanced topics here as well, like what they will be mostly asking here in the interviews. That also we can just have some verbal conversation about that.